Recording in progress.
Probability distribution. So last week also we discussed about probability density function and how to find cumulative probability distributions when we have a probability density function. Okay, so today we are going to start our new chapter, chapter 4, that is probability distributions. The last chapter was based on finding the probability distribution for a discrete random variable or continuous random variable. But here, we are not going to find any probability density function or probability mass function, but we are going to, these probability distributions are defined earlier. Okay, so we are going to learn how to map these probability distributions with experiments or with real scenario. Okay, so as you already know, there are two types of probability distribution. So if we have a discrete random variable, that means we have a discrete probability distribution, or simply we can say probability mass function. Okay, so if we have a continuous random variable in an experiment, then we have probability density function, or we can say continuous probability distributions. Therefore, depending on the type of the variable, there are basically two types of probability distributions. One is discrete probability distribution, other one is continuous probability distribution. Okay, it depends only on the variable. Understand? So first part of this lecture or first part of this chapter will be discrete probability distributions for discrete random variables. Okay, right. Let's look at the definition first. There are so many discrete probability distributions. Okay, so I will teach you what those probability distributions are later. First of all, we need to learn about Bernoulli trial, right? Or Bernoulli experiment or Bernoulli distribution, because it is a probability, discrete probability distribution. Okay, so after learning this Bernoulli trial or Bernoulli distribution, we will learn more probability distributions from discrete probability distributions. Okay, now first look at the Bernoulli distribution and its definition. So what do you mean by a Bernoulli trial? Bernoulli trial. A Bernoulli trial is one of the simplest experiments where we can have one of two possible outcomes, which means the Bernoulli distribution describes some events having only two possible outcomes, exactly two outcomes. For example, if you toss a coin, okay, if you toss a coin, there are only two possible outcomes, either getting a head or tail. So we can consider that event or that experiment as a Bernoulli experiment or Bernoulli trial, because it has only two possible outcomes. Therefore, we can have only one of those two possible outcomes. Or, for example, yes, no. If you take this statistics examination, okay, we can consider that situation as a Bernoulli trial. A student will pass or fail that exam. Okay, there are only two possible outcomes. Either you will pass the examination or fail the examination. So it is also a Bernoulli trial or Bernoulli experiment. For if you take another example, if you take a match, okay, if you consider one team, that team will win the championship or not. There are only two possible outcomes. That team will win that championship or not. Okay, there are more examples that we can consider them as Bernoulli trials. So if you take birds, here I have given that example, birds. How can we map that situation? into Bernoulli distribution. How many boys are born and how many girls are born each day? Actually, if you take a birth, that baby can be either a girl or boy, right? So it is a Bernoulli trial. Actually, in Bernoulli trials or Bernoulli experiments, we phrase those Bernoulli trials as success or failure. Success or failure. If you take a particular exam, if you pass that examination, we can take it as a success. Success, and we can find the probability of success. So if you fail the examination, we can take it as failure, success or failure. If you take the experiment tossing a coin, if you toss a coin, there are two possible outcomes, getting a head or getting a tail. If you take getting a head as a success, then what would be the failure? Getting a tail. Understand, if you toss a coin, there are two possible outcomes, either getting a head or tail. If you take getting a head as a success, then getting a tail would be a failure for that experiment. Understand? Therefore, Bernoulli trials are usually phrased in terms of success and failure. Did you understand what is a Bernoulli trial? Okay, if you want, we can consider rolling a fair die as a Bernoulli trial. How can we map that situation? You know, if we roll a fair die, there are 6 possible outcomes. No? But here, I just mentioned that if it is a Bernoulli trial, then there would be only 2 possible outcomes. Please give me a second, students. It's really noisy.
Recording stopped.
Okay, sorry for the inconvenience.
Recording in progress.
Right. So, if we consider rolling a fair die, okay, we have only 6 possible outcomes. Now, if you roll a fair die, can be either 1, 2, 3, 4, 5, or 6. Now, you might think, how can we map that situation as a Bernoulli trial? So, if it is a Bernoulli trial, it should have only 2 possible outcomes. But there we have 6 possible outcomes. But we can map that as a Bernoulli trial. How? If you take getting number 6, right? If you take getting number 6, if you roll a fair die, okay, as a success, okay. Now success is defined as getting number 6 when we roll a fair die. So we can think getting any other value, any other number as a failure. Understand? So it is also a Bernoulli trial. It can be considered as a Bernoulli trial, rolling a fair die. Understand? So, in Bernoulli trials, first thing you need to understand is there are only 2 possible outcomes, either success or a failure. Okay? Or yes or no. Understand that? Let's move on. A Bernoulli distribution is a discrete probability distribution for a Bernoulli trial. Okay, now we learned what is a Bernoulli trial, and Bernoulli distribution means discrete probability distribution for a Bernoulli trial. Understand? So, tossing a coin is a Bernoulli trial. Understand? Tossing a coin is a Bernoulli trial. And Bernoulli distribution means if you consider the sample space of that experiment, okay, and using the sample space, if you can define a random variable and if you can find a probability mass function for that random variable, that function can be called as a Bernoulli distribution. Understand? So a Bernoulli distribution is a discrete probability distribution for a Bernoulli trial. Here I have given you one example. The probability of getting a head while flipping a coin is 0.5 and let it be simple p. Okay. This says if you toss a fair coin, okay, there are only two possible outcomes, getting a head or getting a tail. If you consider getting a head as a success, what is the probability of a success? What is that probability? Probability of a success? Tell me, what is the probability of a success? I hope you can see my screen. Let's say we toss a fair coin, okay? So sample space should be H or tail, right? Getting head or getting tail. So if you consider getting a head, right? Getting a head as a success, okay? Tell me, what is the probability of getting a head? What is the probability of getting a head if you toss a coin? That should be half. So out of two possible outcomes, we have only not one. The probability of probability of getting a head is not one. That should be 1/2. Out of two outcomes, only one outcome is related to that event. Okay. Therefore, probability of getting a head is half, or probability of getting a tail is again half, right? So if we consider probability, if we consider getting a head as a success, then definitely getting a tail should be a failure, right? Now, probability of a success, right? Probability of a success usually denoted by simple p. Simple p. In this case, that is equal to half or 0.5. Okay, the symbol is used. This simple p is used as the symbol for probability of success. Okay, then tell me, what is the probability of a failure? If the probability of a success is p, then what is the probability of a failure? That should be definitely what? For this experiment, if it was a coin, probability of a failure is 0.5, because probability of getting a tail is half. But if you take the probability of a success as p, then what is the probability of a failure? Please tell me.
1 minus p.
1 minus p. Very good. Because it has only two possible outcomes, so either success or failure. The probability of a success is p, then the probability of a failure should be 1 minus p. Understand? Right. Let's go back to the presentation. The probability of getting a head while flipping a coin is 0.5 and let it be p, simple p. The probability of failure is then 1 minus p. Forget about this 0.5. This in Only in this case, this P is going to be 0.5. Okay. Otherwise, P can have any value in between 0 to 1. Okay. It depends on the experiment, Bernoulli experiment. Anyway, it has only two possible outcomes. Now see this example. Here I have given you a small diagram. Okay. The probability of a success is labeled on the x-axis as 1 and failure is labeled as 0. Sometimes we label the probability of a success or not the probability of a success. We label the success as 1 and failure as 0. Okay, not the probability. I mean, success. It's an assign value. Okay, if you assign number 1 for a success, then we can assign 0 for a failure. Okay, so in this diagram, the probability of a success is labeled as 1 and the failure is labeled as 0. Understand? So my in this diagram, okay, I think yes, in this diagram, not the probability of a success. It's a mistake, right? Success is labeled as 1 and failure is labeled as 0. Okay, not the probability. The probability of being success is 0.4 in this case. Here, the probability of success is 0.4. You can see that here, the y value corresponding to 1 is 0.4. That means the probability of success is 0.4. Then what would be the probability of failure? Definitely it should be 0.6. 1 minus 0.4. Understand? Here, success is labeled as 1 and failure is labeled as 0. Okay, so if you draw this situation in a XY coordinate system, this is 0, this is 0, this is 1. And if the probability of success is 0.4, then definitely probability of failure is 0.6. So you can draw this as 0.6. This is 0.4. What you need to understand here, these probabilities can vary. Okay, if it is a tossing a coin, then these probabilities are equal. That is 0.5. Understand? Like this. So if you take rolling a fair die, okay, rolling a fair die, in this case, if you take success as getting number 6, what is the probability of the success? In that case, probability of a success. That should be, if you roll a fair die, there are 6 possible outcomes, either 1, 2, 3, 4, 5, or 6. So if you consider getting number 6 as a success, what is the probability of a success? That should be 1 out of 6. Then what is the probability of a failure? Yes, one of you have given the correct answer. Failure. The probability of a failure, that should be 5 over 6. 1 minus 1 over 6. That should be 5 over 6. Anyway, the addition should be 1. That is the total probability. Since it has two possible outcomes, therefore, that should be 1 minus P. Okay, in that case, if you draw the distribution like this, if you label success as 1 and failure as 0, okay, this is 0, then what is the probability of 1? That is 1 over 6. 1 over 6. The probability of a failure is 5 over 6. It should be somewhere here, 5 over 6. Okay. So, what you need to understand here is these values of P, right, can vary with the Bernoulli experiment. Understand? Sometimes it can be equal, P and 1 minus P can be equal, but sometimes P and 1 minus P can be not equal. Okay? Okay. I hope you understood how to, identify a Bernoulli trial and Bernoulli experiment, right? Okay, let's go back again. Bernoulli distribution. Let capital X be the random variable of a Bernoulli distribution. So there's a Bernoulli distribution. That means we have a Bernoulli trial. So in that experiment, we define the random variable as capital X. Okay, that is either a success or a failure. Here we are going to find probability map. Yes, we are going to map the situation into Bernoulli distribution. So that means we should have values for the random variable. Understand? So getting a success or getting a failure can be taught as values. If we assign number 1 for a success, then we have converted our qualitative data into a quantitative one. Okay, so success is, we assign number 1 to success. Okay, so number 0 is assigned for failure. Therefore, we defined our capital X as what? As a success or a failure. If it is a success, then value of capital X is 1. If it is a failure, value of capital X is 0. And you know, if capital X takes some values, we write those values using simple letters. Therefore, simple X is equal to 1 if it is a success, and simple X is equal to 0 if it is a failure. So in Bernoulli distributions, the random variable capital X has only 2 values. It can be either 0 or 1. 1 represents success and 0 represents failure. Okay. Therefore, the probability mass function of the random variable X can be written as follows. You know, if we have a discrete random variable, we could find the probability mass function of that discrete random variable. So here we discuss about Bernoulli distribution. In Bernoulli distribution also, for this Bernoulli distribution also, we can find, or we can write the probability mass function, okay, as a mathematical function like this. Okay, now the random variable capital X is a value, can be either 0 or 1. 1 represents success, 0 represents failure. When the random variable X takes number 1, what is the probability of a success? That is simple P. When X equals 0, that means when there's a failure, then the probability of a failure should be 1 minus P. Okay, so that is called the probability mass function, or we can say that probability distribution. Okay, probability distribution of the random variable capital X for a Bernoulli distribution, right? For a Bernoulli trial. Understand? So it can also be written as this. Oh, okay, I will explain this with you. Give me a second. Now I told you success is considered as number 1 and failure is considered as number 0. Therefore, X can have only 2 values, either 0 or 1. That is the random variable. Okay, for a Bernoulli experiment or Bernoulli distribution. Right? So how can we write the probability mass function? You know, it is a discrete. We have discrete random variable, either 1 or 0. Right? 1 represents success, 0 represents failure. Therefore, X is a discrete random variable. And you know, if we have a discrete random variable, we would write the probability mass function using capital P, Px6. Okay, Px6. So that is equal to simple P, okay, simple P when X equals 1. If it is a success, I told you, we take simple P to represent the probability of a success. If it is a failure, the probability of a failure is 1 minus P. So this is called probability mass function of the random variable X. Or we call Bernoulli distribution. Bernoulli distribution, because this random variable has only 2 values, 2 outcomes, 2 values. So it's a Bernoulli trial or Bernoulli random variable. Therefore, this probability mass function is called Bernoulli distribution. Understand? So we can write this equation or this function like this. Let me check that. P to the power X, 1 minus P, 1 minus X. Yes. And for X equals 0 or 1. Yes. Can you understand this formula? This function? If you substitute X equals 0, right? When X equals 0, what happens to this probability mass function? When X equals 0, P to the power 0, 1 minus P to the power 1 minus 0. Then P to the power 0 is 1. 1 minus P to the power 1 minus 0 is 1. Therefore, 1 times 1 minus P to the power 1, which gives 1 minus P. That means when X equals 0, the probability of a failure is 1 minus P. We have got the same answer like this. When X equals 0, the probability is 1 minus P. Here also, if we substitute X equals 0 in the formula, in the function, we would get 1 minus P. That is the probability of a failure. Understand? Now substitute X equals 1. When X equals 1, here actually 0, this is 1. P to the power, we had simple X, now X is equal to 1. P to the power 1, 1 minus P to the power 1 minus X. Now X is equal to 1. P to the power 1 is P times 1 minus P to the power 1 minus 1 is 0. You know 1 minus P to the power 0 gives 1. Therefore, we will end up with P, simple P. Okay. And you can see that when x equals 1, the probability of a success is simple P, and that is same as this. Right? When x equals 1, the probability is P. When x equals 0, probability is 1 minus P. Here also, when x equals 0, the probability is 1 minus P. And when x equals 1, the probability is P. That means Bernoulli distribution can be written in two ways. Okay, either you can write it as this P1 minus P. This is x equals 1, x equals 0. Or you can write the same formula as P to the power x, 1 minus P to the power 1 minus x for x equals 0 and 1. Understand? So there are two methods to represent the Bernoulli distribution. So did you understand how to write the Bernoulli distribution or the probability mass function for a Bernoulli random variable? Yes or no? Did you understand it, students? No, students, can you hear me? Did you understand how to write the probability mass function or the probability distribution for a Bernoulli random variable?
Yes, madam.
Yes, madam.
Right. If you can, if you understood that, I will give you a small task. That is, you have to show that the expected value of a Bernoulli random variable is going to be simple P, and the variance of a Bernoulli random variable of x is going to be P times 1 minus P. Can you show that? Yeah, I have given you the result, but you have to show that. So how you are going to show that? The expected value and the variance. Last week, I couldn't upload my lecture note to the Google Classroom or LMS. Today morning, I just uploaded it. If you are, if you cannot remember the formula that we use to find the expected value of a particular random variable and the variance of a particular random variable, I can give you the formula. Using that formula, you can just find these two, you can just get these two results. Okay, I will give you that formula here. Quickly find the expected value and the variance. You will, anyway, you have to get the expected value as P and the variance as P times 1 minus P. So this is the formula. Actually, we had two different formulas for discrete random variables and continuous random variables. If it is a discrete random variable, right? Discrete random variable, then the expected value of x is equal to xp. xp for all x. If it is a continuous random variable, then the expected value of x is equal to from minus infinity to plus infinity integral x fx dx. So these are the two formula that we use to find the expected value of a particular random variable x. Okay, if it is a discrete, we use this. If it is a continuous one, we use this. Okay, and the expected, the variance of x, that is equal to expected value of x squared minus expected value of x whole thing squared. So can you show that? Can you show the expected value of a Bernoulli random variable is P and variance is 1 minus P times P? You have to show these two things. Can you show that? Okay, I will give you the first step. Okay. Here. Now, what is the distribution? Probability mass function we found as p to the power x 1 minus p to the power 1 minus x for x equals 0 and 1. So this is the probability mass function we have. Therefore, we have to use this formula since we have probability mass function. Okay, we are not going to integrate any function because we do not have any continuous random variable here. You know, Bernoulli random variable is a discrete random variable. Therefore, we use this formula xpx to find the expected value. Okay. Now, what is the first value of x? X can be either 0 or 1. So, substitute first 0 here. 0 times p 0 plus. Now, substitute x equals 1. 1 times p 1. Okay. Right. 0 times. What is the probability of a failure? X equals 0 means failure. Now, what is the probability of a failure? You can find that probability by substituting x equals 0 in this formula. What is the formula? Simple p to the power 0, 1 minus p to the power 1 minus 0 plus 1 times this 1 and 0 means this x, okay? P of 1, that means the probability mass function when x equals 1. So substitute x equals 1 in the probability mass function. Therefore, we would get p to the power 1, 1 minus p to the power 1 minus 1. Right? Here. No matter the value we have here, it should be multiplied by 0. No? Therefore, we would get 0 plus 1 times p to the power 1, 1 minus p to the power 1 minus 1. That gives 0. So, 1 minus p to the power 0 is again equal to 1. Therefore, 1 times p times 1. 1 times p times 1. Finally, you have p. Like this. That means the expected value of a Bernoulli random variable is simple t. Okay. Now we have found the expected value. We need to find the variance. I have given you the formula for that. That means we need to find this expected value of x squared. Let's find that term first. Expected value of x squared. The formula is for all x, x squared dx x. First substitute x equals 0, 0 squared p0 plus 1 squared p1. Means substitute x equals 1. Now 0 squared means 0 times p0 means what? Here we have found it. P to the power 0, 1 minus p, 1 to the power 1 minus 0 plus 1 times again p1. P1 is found as p. Here p of 1 that is equal to p. If you want, you can substitute x equals 1 in the formula, in the probability mass function to find the p of 1. But I'm not going to find that term again because we have found it in earlier case. So that is equal to p. So finally we have this is 0, again p. The final value is p. Right? That means the expected value of x is p and expected value of x squared is also p. So this is not the variance. What is the formula for variance? For the variance, that is expected value of x squared minus expected value of x whole thing squared. Now substitute these terms in the formula. The expected value of x squared was found as p. minus expected value of x, again we found as p and holding square. That means p squared. So p minus p squared, that is equal to p times 1 minus p. So this is the variance of the Bernoulli random variable, of a Bernoulli random variable. Understand? So for any probability distribution, we should know its mean and the variance. Then it would be better for us to find particular probabilities. Okay, if we know the random variable, either it's a continuous one or discrete one, then we just can find its probability distribution. Either it's a probability mass function or probability density functions. If we know for a particular random variable, if we know the probability density function or probability mass function, then we can find any probabilities. Okay, we can find any probability, but it's important for us to know the expected value and the variance of a particular random variable in any probability distribution. Therefore, if we are going to find probability density function or probability mass function of a random variable, we have to find both terms, mean and the variance for the same distribution. Understand? Because I will teach you why we should know that two terms, mean and variance, in the next section of this chapter. When you come to the probability, continuous probability distributions, you will know the reason for that. Okay, why we should know the mean and the variance. So here I'm not going to do that part, but remember one thing: if we are going to find any probability distribution, we should know its mean and the variance. Understand? So let's go back to the slide presentation. Okay, here for a Bernoulli distribution, we have found the expected value as p and the variance as p times 1 minus p. Okay. Let's move on to the next slide. Binomial distribution. An experiment consists of n independent Bernoulli trials is called binomial experiment. Okay. Now, tell me, before going to the binomial distribution, did you understand about the Bernoulli distribution well? Yes or no? Did you understand the Bernoulli distribution? Please tell me, guys, because binomial distribution depends on the Bernoulli distribution, right? It's an extension of Bernoulli distribution. Therefore, you should know about the Bernoulli distribution well. Without knowing it, you cannot do binomial distribution, right? Okay, one of you said yes. Others, did you understand? Yes or no? Please tell me.
Yes, madam.
Okay, others? Yeah, I will give you just an introduction about binomial distribution. We will do binomial distribution tomorrow as well. But let's do this. Binomial distribution. An experiment consists of n independent Bernoulli trials is called binomial experiment. Okay, the experiment consists of fixed number of trials n. Each trial has two possible outcomes, success or failure. The probability of success is the constant for each trial, that is p, and those trials are independent. So did you understand what the meaning of binomial experiment? You know, Bernoulli experiment is an event having exactly two outcomes. Bernoulli experiment, like tossing a coin once. Tossing a coin once. If you toss a fair coin once, you will have only two possible outcomes. Okay, so you can have one of those two possible outcomes at once. But here in binomial distribution, it says an experiment consists of n independent Bernoulli trials. In a binomial distribution, there are n number of Bernoulli trials. That means if you toss a fair coin two times, then we can consider that as a binomial distribution. Why? If you toss a fair coin once, that's a Bernoulli. We are tossing the same coin again. Again, it's a Bernoulli. Or we can toss the same coin again. Again, it's a Bernoulli. So there are three Bernoulli trials. Or if we want, we can toss that coin again. Likewise, we can have n number of Bernoulli trials. Bernoulli trials. N number of Bernoulli trials. So now it's going to be not the Bernoulli experiment. It's a binomial experiment. It says an experiment consists of n independent Bernoulli trials is called binomial experiment. Understand? Here, further it says the experiment consists of fixed number of trials. It has fixed number of trials, simple n. So if you toss a fair coin two times, the value of n is 2. If you toss a fair coin 3 times, then what is the value of n? How many Bernoulli trials are there? If you toss fair coin 3 times, 3. If you toss a fair coin 5 times, how many Bernoulli trials are there? 5 times. 5. Understand? So each trial, each Bernoulli trial has two possible outcomes, success or failure. The probability of success is a constant for each trial, that is P, and those trials are independent. That means outcome of any event, any trial does not depend on the outcome of any other trial. Understand? They are independent. Outcomes of each trials are independent. So if any experiment follows these 4 properties, then we call it as a it's a binomial experiment. Understand? Did you understand it? Please tell me. No. If we toss a fair coin once, then sample space is getting him or tail. So it's a Bernoulli, right? Bernoulli trial. That is the first trial. If you toss the same coin again, that is the second Bernoulli trial. Bernoulli trial. Right? Bernoulli trial. Likewise, you can toss that coin at any time. I mean, 2 times, 3 times, 4 times, 5 times. Likewise, n number of times, n times. And you can see that each trials are independent, and in each trial, probability of a success is P, right? Failure is 1 minus P. In each trial, P 1 minus P. P 1 minus P. Understand? Therefore, we can consider this experiment as binomial experiment. Binomial experiment. Understand? Right. An experiment consists of n independent Bernoulli trials is called binomial experiment. The experiment consists of fixed number of trials n, the same properties as in Bernoulli. Okay, only the difference is in Bernoulli we had only one trial, but in binomial there are n number of fixed trials, fixed number of trials. N. That n can be either 1, 2, 3, 4, 5 or any value, any integer value. Okay, positive integer value. Right. Now go to the formula. Right. So if we want to find the binomial distribution or the probability mass function of a binomial random variable, we need to know about permutations and combinations. Okay, so I will teach that part tomorrow about actually here you will need to know about combinations, not permutations, combinations. So you tomorrow I will teach you how to find combinations. Okay, then we will define the probability mass function of a binomial random variable. Okay, so today we just discussed how to identify a Bernoulli trial and how to write the probability mass function of a Bernoulli random variable. Okay, and tomorrow we will discuss about binomial distribution and its probability mass function. And let's find the expected value and the variance as well for a binomial distribution or for a binomial random variable. Okay, so far did you understand about Bernoulli random variable and Bernoulli trials? If you have any question regarding today's lecture, please ask me now. Otherwise, I can stop the lecture for today. It seems like you don't have any question regarding Bernoulli distribution or Bernoulli trial. So I'm going to stop the lecture for today. Thank you for joining the lecture.